All right, we're going to talk about one of our important tests here. It's called the first derivative test. As a preliminary, you need to know a few things in here. Okay, let's see. Okay, so in here, we have what it means to have a function increasing. Essentially, visually, it's what you think it is. As you look at the function left to right, it goes upward. A point, taking 2 points, x1 and x2, you always have an increase in the function as you move from one to the other. Decreasing is backwards. As you move left to right, the function on the left is, point on the left is always higher than the point on the right. Okay, now, also, we have a test for increasing, decreasing functions. If we have a continuous function on a closed interval and it's differentiable on the open interval, then in here, if f prime, in other words, if the derivative is positive, then f would be increasing on that closed interval. If f prime is negative, then f would be decreasing on the closed interval. So, and then the third case would be if f prime is equal to 0. So in other words, it's not increasing, it's not decreasing. We have a constant function. Now, using that and our knowledge of what it means to have a relative extrema, along with critical numbers, what part they play, then we have the basis for the following test, the so-called first derivative test. And it's really simple. Graphically, all it means is this. You have a critical number. You have a critical number. Then, let's see, it's a little bit heavy. Okay, if you have a critical number, then essentially you're going to have a graph that looks something like this. Okay, or it might look like this. Or it might look like this. Or even like this. Okay, but let's consider this case over here. As you move through the point C, you'll notice the derivative is positive coming into the point and negative leaving it because the function is increasing and then decreasing. That would indicate a relative maximum. And the point is that you don't have the graph before you check this, before you do the test. You're doing the test on the derivatives before you have a picture, and you'll be able to form the picture from the results of the test. Okay, so if it changes from positive to negative, then you have a maximum. If it changes from negative, like this case down here, and then all of a sudden goes positive, okay, in other words, negative slopes coming this way, positive, then you have a minimum. Likewise over here, notice I'm going into an undefined derivative here. But I have negative slopes, and then all of a sudden they become positive after I get past that point at the bottom. Another relative minimum. Okay, so that's the test, and let's see what happens. Now, also you can have a situation like this. This is case 3. You might have a graph that looks like this coming into a critical number. So you definitely have a horizontal tangent here. And yet, it was increasing going in and moving to the right. Now it's still increasing coming in here. In other words, the slopes are still positive. as you pass through this point, you have zero slope, but then you have positive. And it can go the other direction also, where you hit this point here, zero slope, but negative coming in and negative leaving, negative slopes. So that, in that case, we do not have a relative extremum. Okay, do not.